Hi friends, welcome to our channel Jayaditya Math Tutorial. In the series of Ncert class 11th, we are now in the chapter sets. In our previous class, we have discussed the exercise problems of exercise 1.1. That problems are related to set builder forms and roster forms and to find whether the given collection is a set or not. Okay, so in this class we are going to discuss about some more interesting concepts and some problems related to those concepts. So please do watch till the end, and if you are new to my channel, please do subscribe. If you like my class, please do like and share with your friends. So without wasting any time, let us enter into our class. Right now, so let us understand a situation here. So what is that in the sense? For example, let us take a collection or set such that x is a student presently studying in 9th class. And let us take the other set such that x is a student presently studying 9th and 10th class. Right now, let us look at some situations here. What are those? So the first situation is about the set x such that x is a student presently studying in 9th class, or the second one is x such that x is a student presently studying in 9th and 10th classes. Okay, so if you observe these statements, you should understand one thing here. What is that in the sense? So no student will be studying 9th and 10th classes at a time right now. So here we are talking about a single student who is studying both 9th and 10th classes, right? So there will be no such students, right? But in the first case, so if you observe x such that x is a student presently studying 9th class, yes, in 9th class there will be some finite number of students, right? They will be studying 9th class, but we will not have any student such that he is studying 9th and 10th classes at a time. Clear, Nana? So see here, in the first case we can write the roster form, okay, but in the second case, to write the elements in the roster form, we will not have any elements. That means there will not be any student, right? There will not be any student such that he is studying both 9th and 10th classes at a time. So see here, so here we will be having some definite number of elements in the first case, but in the second case we will not have any number of elements, right now. So we will not have elements at all. So this kind of set, so the set which is we are representing in B, right? So B is the set is known as empty set now. Why? Because here we will not have any elements to write them in the set. So we call this B set as what? So that is known as empty set. Clear? So this concept is very important. Empty set is also known as void set, and it is also known as null set. Clear now? So whenever you are seeing the names of sets such that empty set, void set or null set, so what you should understand here, so such that the set contains no elements. So what can you say about empty set now? So the set which does not contain any element is known as empty set now. So what is it? The set which contains no element is known as empty set, or it is also known as void set, or it is also known as null set. So let us take some more examples and let us see about some null sets here. Right, Nana? See here I have written some examples of sets. So let us see whether these sets are empty sets or not. So how to check them? So what is our first set here? X such that x is a natural number. Okay, x is a natural number, and what is the condition given here? 1 less than x less than 2. That means x must be a natural number and it must lie between 1 and 2. Is it possible? No, why? Because 1 is a natural number, 2 is it's a successive natural number, right? So between two successive natural numbers you cannot bring out one more natural number. So here the set is an empty set. Why? Because we cannot have any values for x in the first case. Why? Because x is a natural number here. So if he asks that x is a rational number, means yes, we can find out the values of x here, like 1, 3/2, right now. But here x is a natural number, therefore we will not have any other natural number between 1 and 2. Why? Because x is 1 less than x less than 2. That means x lies between 1 and 2. 1 is a natural number, 2 is a natural number, and between them we don't have any natural numbers. Therefore the first set is an empty set. Clear now? So that is an empty set. And let us go for the next one. So this is B, x such that x square minus 2 is equals to 0. So this is our x element, and x is a rational number. X is a rational number. So let us observe what happens here. So he has given that x square minus 2 is equals to 0. So if x square minus 2 is equals to 0, what should be x square, Nana? X square must be 2. And what will be x here? It will be like plus or minus 2. Here we know that root 2 is an irrational number but not rational, right? Here root 2 is an irrational number but not rational. But in the question he has given that it is a rational number. So again this set is also an empty set or void set or null set. Why? Because x will be here, actually here the x will be an irrational number, but he is telling that x is a rational number. So we will not have any element such that it is a rational number and satisfies the condition. Clear now? So let us go for the next one. See, the set of all x such that x is an even prime number. Okay, up to here it's fine. Even prime number greater than 2. Even prime number greater than 2. Actually we have only one even prime number, that is 2 right now. So we have only one even prime, that is nothing but 2. So he is telling that x must be greater than 2, it seems, and x must be even and also prime. Even and also prime. Is this case possible here? No, we will not have any element greater than 2 such that it is a prime number and even number. We will be having prime numbers 3, 5, 7 like that. But all the prime numbers greater than 2 are all odd numbers only but not even numbers. Clear? So therefore here also we don't have any elements. So therefore this set is also a null set. Clear now? Null set or void set or empty set. So let us go for the next one here. X such that x square is equals to 4. X square is equals to 4, and he is telling that x is odd. X is odd. So you should know one basic condition, that square of an even number will be always even. Square of an odd number will be always odd. So you can check it. 3 square, 9 is an odd. 3 is an odd, and 3 square is 9. 9 is also odd. 5 square, 5 is odd. 5 square is equals to 25. 25 is also odd. So see here, but we have here x square is equals to 4, which is even, right now, which is even. So square of an even number only will be even here. Therefore x must be even, right? X must be even, but he is telling that x is odd. So this case is also not possible. Therefore we can say that this set is also a null set or void set. Clear? Clear now? So you should remember all the names of an empty set. So empty set is also known as void set, or it is also known as what here? That is null set. Clear? So how to represent a null set or void set or empty set? So let us see here how to represent it. So see here, Nana, if you observe all the cases, if you want to convert the set builder forms into roster forms, you will not have any elements in the braces, right? So you can simply say that within the braces you will not have any elements. So this is one kind of representation of null set, and it can also be represented by phi. This symbol is known as phi. So you can also represent a null set with a phi. So see here, A is a null set. You can mention like this, or simply no element within the curly brackets. And here also the same thing. So you can mention either like this or within the curly brackets. So I am mentioning like this. So this is a null set, and D is also a null set. So whenever you see this symbol, you should think that it is a null set and there are no elements in the set. Clear now? Even that symbol is also denotes the empty set. So let us go for some other concept here. Right, Nana? Look here. Here I have written some sets here. Let us understand about these sets. Okay. What is the first one here? The set is A. In set A we have the elements 1, 2, 3, 4, 5. Right, Nana? So can you say how many elements are there in this set A? Yes, we have 5 numbers here. We have what? We have 5 numbers. Therefore, we can easily say that we have 5 elements, right? We can easily say that we have 5 elements in set. So let us go for B. What are the elements we have in B here? That is A, B, C, D, E, F, G. So total how many elements we have here? So A is one element, B is one element, C 3, 4, 5, 6 and 7. So total we have 7 elements, right, Nana? So we have how many? That is 7 elements. Clear? And let us see the C set. In the set C, what is the set C contains here? Men living presently in different parts of the world. So this is nothing but it is the people. It is a collection of people presently living in different parts of the world. So the number might be bigger, but definitely there will be some number, right? So it will be approximately like 700 crores like that, right? So it has some particular number of elements, but the number is bigger. So simply you can write here we have some definite number of elements, right now? So we can easily say that we have some definite number of elements here, right? So in the first case we have 5 elements, in the second case we have 7 elements, and in the third case we have some definite number of elements, but we don't know that number exactly, but there will be a particular natural number, right now? So you will be counting like this only, 700 crores like that, right? So let us go for the next one. Set of all natural numbers. How many natural numbers you have? Can you tell that there are some particular number of natural numbers? No, the number of natural numbers or collection of natural numbers will have many natural numbers, right now? So here we cannot say the number of natural numbers. Listen carefully. Here we cannot say the number of natural numbers. So here the number of natural numbers is like infinite. Why? Because we don't have a finite number here. Clear? So you observe set C and set N. So in set C, men living presently in different parts of the world. Though we don't know the number, but we can easily say that there will be a particular definite number of people living in all the parts of the world. But here, in case of natural numbers, these are infinite. So you should understand the minute difference here. Clear? So if you observe up to here, in first three cases, you can say the elements have some definite number, right? Elements are of some definite number here. In first case we have 5 elements, in second case we have 7 elements, and in third case we have approximately 700 crores like that. So there will be a definite number. So this kind of sets we call as finite sets. What do we call them, Nana? So we call these kind of sets as finite sets. This word is important. Clear? And when you come to the natural numbers here, set of all natural numbers, here the number of elements is infinite. Number of elements is infinite. So we cannot count the elements in the set here. Therefore, we call this kind of sets as infinite sets. Okay, now what do we call it? Infinite sets. So these are the other two kinds of sets here, that is finite sets and infinite sets. Now clear? So see here, if you observe one thing here, number of elements in set A, you are telling that there are 5 elements. So this can be represented as n of A. N of A. That means what here? What is it, the meaning of n of A here? Number of elements in set A. So you can say number of elements in set A is how much? That is nothing but 5. So number of elements in set A is 5. Similarly, you can say this one also. What is number of elements in set B? That is 7. So here you don't know the number, but we can say approximately 700 crores like that. So see here, number of elements in a set is also known as cardinal number of that set. So what do we call that number? Cardinal number of the set. So what is it? Cardinal number. So it is simply represented that, for example, there is a set S. So if you want to find out the number of elements in set S, simply you can see, you can show like this, n of s. N of s in the sense that is nothing but cardinal number of a set. So simply, now I will ask you a question. So you try to guess the answer and give the answer in the comment box now only. Pause the video and give the comment section. After I reveal the answer, you check it. Okay. So see here, what is the cardinal number of an empty set? That is my question. What is the cardinal number of an empty set? So now you post the comment here. Pause the video. Post the comment. Right. So see here now. So what is my question here? What is the cardinal number of an empty set? So I am already telling you that the set is empty. So how many elements will be there in that particular set? So in that particular set we will not have any elements. So you can simply say that there are 0 elements. So what is the cardinal number of an empty set here? That is nothing but 0. So whenever you find something, so cardinal number of empty set will be always 0. So keep this in your mind. So congratulations if you have given correct answer here, right? Right now. So let us go for the next. Let us check whether the given sets are finite sets or infinite sets. So these are some 3 examples we have here. So let us see whether these sets are finite or infinite. Clear? So what do we call the number of elements in the set? That is nothing but cardinal number. Clear now? Right now. So what is the first one here? W is equals to set of days of the week. Set of days of the week. So in week, how many days you will be having? You will be having 7 days, right? Sunday, Monday, Tuesday, like that. So you will be having 7 days. So simply you can write here n of W is equals to 7. N of W is equals to 7. So whenever you are telling the elements, number of elements in the set, then the set has some definite number of elements. That means the set is what kind of set it is? It is nothing but finite set. What it is, Nana? That is finite set. Let us go for the next one. S. S is the solutions of the equation x square minus 16 is equals to 0. So solutions of the equation x square minus 16 is equals to 0. So how to solve this one? So you can simply write like this. X square 16 can be written as 4 square, right, Nana? X square minus 4 square is equals to 0, and this is in the form of a square minus b square. So you can write like this, a plus b into a minus b is equals to 0. So if product of two numbers is equals to 0, either of the numbers should be 0. So I am taking two cases here, x plus 4 is equals to 0 and x minus 4 is equals to 0. If I take x plus 4 is equals to 0, I will get x is equals to minus 4, and if I take x minus 4 is equals to 0, I will get x is equals to 4. So how many solutions I have now? So x is equals to minus 4 and x is equals to plus 4 here. So I have two solutions. So I can easily say that number of elements in the set S, number of elements in the set S is nothing but it is equals to 2 here. Right now, that is equals to how much? That is 2. Again we got a finite number here. So simply by looking also you can say that this is a finite set. What kind of set it is? That is a finite set. Let us go for the last example. So G is equals to set of points on a line. Set of points on a line. So in our lower classes only we have discussed that what is a line actually? Line is nothing but it is the collection of points, right? Line is the collection of points. So see here, he is talking about line. So line can be extended in either of the directions, right? In both the directions the line can be extended. So can you say how many points are there? For example, if you count here 100 points, there will be 101 point here. So this will be extending in both the directions. Therefore we cannot count the number of points on the line here. So here, so set of points on a line means we will be having how many points now? We will be having infinite points. Therefore what kind of set is G here? The set G is nothing but infinite. Clear? So what kind of set is G here? G is infinite set. I hope this concept is clear for you, right, Nana? So if you have any doubts, you do comment in the comment section. I am always ready to clear your doubts. Let us learn some more information about finite and infinite sets. Right, Nana? Look here. So here I have taken two sets. So the first one is x such that x square minus 16 is equals to 0. That is the first set. And the other set is B, x such that x is a natural number. So see here, already we have discussed just now, that is in this set we have how many solutions? X. So how many values x can take here? Just now we have done it. That is minus 4 and plus 4. So this is in the form of set builder. This is in set builder form. So Can you convert this into roster form? Yes. So how to convert this one? So by checking the values, so you can simply write it as -4 comma +4. That's all. That will be the roster form of set A here. Clear? And whenever you are talking about set B, so see here, what is set B here? X is such that X is a natural number. So if you observe set A and set B, here we have only finite number of elements, so we have written within the braces, right, Nana? But X is such that X is a natural number. Can you write infinite numbers in the set? So when you want to convert a set into the roster form and infinite set into a roster form, so you cannot write all the elements within the braces. So you will be having infinite number of elements. Can you mention infinite number of elements here? No, that is not possible. So for that reason, what we will be doing simply, so X is a natural number, right? So it follows some particular pattern here. So how it will be? So natural numbers will be like this: 1, 2, 3, 4. Okay, so on. It continues like that. So in order to show that the continuation, simply we will be putting 3 dots here. So what these 3 dots says that, so the set is not completed and it is continuing. So you can easily say that just by looking at the symbol also, you can easily say that it is an infinite set, right? So here we have not put any dots here. That means that is a finite set. Here we can write all the elements. What are the finite number of elements? So you can mention here, but here it is not possible. Therefore, in order to convert it into roster form, simply we will be writing the first 3 to 4 numbers or 4 elements, and just by putting 3 dots, you can show that it has a pattern here. So see here, the difference is always 1, right? Difference between the elements is always 1. So it has a pattern and it continues. So all the finite sets you can show in roster form, but some infinite sets also, like set of natural numbers, you can show it in roster form. But can you show the other set such that X is a rational number? X such that X is a rational number. Can you write this set in the roster form here? No, you cannot represent this kind of set in roster form. Why? Because it is a rational number. It will not have any pattern. Some numbers will be like fractions, some number will be like terminating or repeating decimals. So there will be different kinds of numbers in rational numbers, right now. So you can also write natural numbers, you can also write whole numbers, you can write integers. So there will be many kinds of numbers. So you cannot show this set in the roster form. So keep in mind, so we cannot show all the infinite sets in the roster form. Clear now? So let us see some more examples and to understand the concept very clearly. Right, Nana? Look here, we have taken some more examples here, and here just we should identify whether the given set is a finite set or infinite set. So see here, what are the sets here? X is such that X belongs to N and X minus 1 into X minus 2 is equals to 0. Just now we have discussed, right? So X square minus 16 is equal to 0 means we have factorized it and we have found it that the values are -4 and +4. So in the same way, if you equate X minus 1 is equal to 0, you will get 1, and X minus 2 is equal to 0, you will get X value as 2 here now. So if you convert this one into roster form, the elements in the roster form will be 1, 2. So you can see that there are finite number of elements in the roster form. So what kind of set is it? So this is nothing but finite set. Clear now? And let us go for the next one. X such that X belongs to natural numbers. X such that X belongs to natural numbers and X square is equals to 4. Here you should be very careful here. So see here, X square is equals to 4, right? Actually, if you bring the square to RHS, it will be under root 4 and you will be having plus or minus 1. Actually, what values you should get here? That is plus root 4 and minus root 4. And here you will be getting root 4 is nothing but 2 and minus root 4 is nothing but minus 2. Now you tell me how many elements are there in this set, Nana? Can you tell it? So see here, but you will be telling that there are 2 elements, but this is absolutely wrong. Why? Because see here, what is the condition he has given? That is X belongs to natural numbers. Only 2 is a natural number but not minus 2. So you can say that how many elements are there in this set means only 1 element. So the set which contains only 1 element is known as singleton set. Now what it is called as? Singleton set. The set which contains only 1 element is known as singleton set. So set which contains no element is, that is nothing but empty set or void set. So you tell me one more condition, one more answer for me. What is that is? whether the empty set is a finite set or infinite set, or nothing, or none of the above. So see here, how many elements do you have in an empty set? 0. That means you are telling a particular number, right? So we have 0 elements. That means there is some definite number there, right now. So empty set is also a finite set. Everyone must remember this one. Clear now? Empty set is also a finite set. It is not infinite. Clear now? So see here, the next one is the same case. X such that x belongs to natural numbers and 2x minus 1 is equals to 0. Right now? So what is the condition he has given that? That is 2x minus 1 is equals to 0. So if you simplify, what happens here? 2x will be 1 and x is equals to 1 by 2. Now you tell me, how many elements are there in the set now? Yes, this time you are right. 1 by 2 is not a natural number. In the condition he has given that x is equals to, x belongs to natural numbers. 1 by 2 is not a natural number. So you can simply say that it is an empty set. It is an empty set. We don't have any element, and also this is a finite set. Right now, so if you observe, these are all finite sets only. Let us go for the next one. X is such that x belongs to natural numbers and x is prime. X is prime. So how many prime numbers are there in set of natural numbers? Natural numbers are infinite. Obviously, the number of prime numbers also will be infinite. So you can simply say that this is what set now? That is infinite set. And what about this one? X belongs to natural numbers and x is odd. So what kind of set is this? Finite or infinite? Please do comment in the comment section, then I will understand that whether you have understood the concept or not. So I hope you have understood this concept very well. If you have any doubts, you do comment in the comment section, and if you are new to my channel, please do subscribe. If you like my class, please do like and share with your friends, and don't forget to hit the bell icon. Whenever you are watching a class, please do watch it till the end. So in our next class, we will be talking about some other concepts and some problems related to those concepts. So don't miss any class of this series. So we shall meet in our next class. Till then, bye.